This is a quick video demonstrating interfacing a Nintendo Wii MotionPlus to a Microchip PIC Microcontroller. On the hardware side of things, we have a Microchip PIC18F4550 microcontroller, have a standard character LCD, have a genuine Nintendo Wii MotionPlus. This provides 3 axes of gyroscope data. Connecting it to our PIC is an extension cable, as well as something called a Wii Chuck. The Wii Chuck is a breakout board for Nintendo Wii accessories. It allows you to break out the I2C data and clock, as well as power and ground. Now, because my microcontroller operates at 5 volts and the accessories operate at 3.3 volts, I'm having to do some level conversion. That's what these 2 transistors here are doing. They're 2N7000 N-channel MOSFETs. Also, because it's at 3.3 volts, I need to tone down the voltage from 5 volts to about 3.3. I'm accomplishing this through 2 diodes here to knock it down to about 3.6. Powering this, and for programming, I use a PIC2 clone. This is called a Mini-Kit 2. It's the same thing. Lets me program it and power it. So let's go ahead and power it up. Plug it in. Starting, it's initialized, and here are our values. So from left to right, we have yaw data, roll data, and pitch data. And if you saw my nunchuck video, you know that I took the top 8 bits of data that time around. This time I'm just going to include the full 14 bits of gyroscope data that the MotionPlus provides. So let's go ahead and check it out and see if it works. You can see I'm holding it still right now. The values it centers at are kind of interesting. I don't know why they are what they are. It is a 14-bit data that you get from the gyro axes, so it should be about 8200. It is about 8200, but they seem to be, I don't know, off a little bit on each one. So definitely, if you're going to use this in an application, you're going to want to calibrate to 0 your device whenever you power it up, so you know where the 0 points are. So let's go ahead and check out the yaw. If I rotate it this way, you see it increases. If I rotate it back, it decreases. So increase, decrease, increase. Seems to be working. Let's check out the roll. So if I go ahead and roll it this way, it decreases. Roll it this way, it increases. Decrease, increase. And the pitch, let's go ahead and pitch it this way, decreases, pitch it the other way, it increases, back and forth. Now the ones you see next to the Y, R, and P are something called the slow bits. The gyroscope chips in the MotionPlus can provide 2 modes of operation. In one mode, it's called the slow mode. It can measure up to 440 degrees per second of rotation. But in the fast mode, it'll provide up to 2000 degrees per second rotation. So the slow bits are a way for the MotionPlus to signal to the Wiimote that the device is being rotated fast, and to take the numbers to mean something else. So for instance, whenever you're in slow mode, your values are going to be more sensitive. You're going to be able to measure smaller rotations, but whenever you're in fast mode, that same value is actually going to indicate a faster rate of rotation. So let's go ahead and see if I can't trigger the fast rate for the yaw here. Shake it pretty hard. There we go, we got a 0. It's indicating that it's in fast mode. And the value changes to a lower value because it's measuring a faster angle. So let's go ahead and try the same thing for the roll. There we go. And let's try the pitch. Oh, got it. Let's see. There we go. Had it for a second there. So this is just a quick little video to demonstrate interfacing the Wii MotionPlus to a Microchip PIC microcontroller. You might want to check out my other video where I interface a nunchuck to a Microchip PIC. The main difference here is that whereas the nunchuck that I used was a Chinese knockoff, this MotionPlus is genuine, so you can just go to the store, pick it up, and be able to interface it with your PIC relatively easily. I'll post the code for this and the nunchuck on my site at musclera.com. That's musclera.com. Thanks for watching.